Hello guys, this is Ronan from MathX, and today we are going to be solving the number 22 from the AMC 2020. Now, this problem, in my opinion, does not deserve the place of number 22. Because if you simply just work backwards, then you can solve the problem easily. But anyways, without further ado, let's get started. So, when a positive integer n is fed into a machine, the output is a number calculated according to the rules shown below. For example, starting with an input of n equals 7, the machine will output 3 times 7 plus 1 equals 22. Then if the output is repeatedly inserted into the machine 5 more times, the final output is 26. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? So, the first step into doing this problem is writing out what the first number, or actually the last number, 1 would be. So, we just start with 1 right here. Now, we have to find out the two numbers that could come before. And those numbers will be represented by the variable n. So it says that if n is odd, then the next number after it will follow the sequence of 3n plus 1. Or if n is even, it would follow the sequence of n over 2. Now, let's see if either one of these work. So if the previous number was even, then it would have n over 2, which works because if you multiply 2 here from this 1, it would just equal 2. But in the other case, if you have the previous number before 1 is odd, then it would have to have 3n plus 1. But the thing is, that just won't work for 1, so we can't include that here. Now that we have these two numbers here, we can basically just work on the next number, which was before 2. So, similar to 1's case, you can't have 3n plus 1 equal 2. So that means the previous number before 2 is an odd, meaning it can only be even in this scenario, because also the n over 2 would work for 2, meaning n is going to be 4, which is the number before it. So let's just write here 4. Now, the numbers that can work before 4, we need to test out. So if the number before 4 is even, then it would follow the sequence of n over 2. And that also works in 4's case, meaning the number before is 8. But also, if the number before is odd, then it would follow 3n plus 1, which also works for 4, meaning the number before 4 is going to be equal to 1. So now, we can find out the two numbers before 8 and 1. So, the first number that will be before 8 can follow either, if it's even, it would have that number over 2, and if it's odd, it would be 3 times that number plus 1. So, it seems that the second case, if the number before 8 is odd, won't work in this scenario. Meaning, we have to go with the first one, which meaning that the number before 8 is even and is 16, because 16 also works. And similar to the first number we wrote here, which was 1, it will have the same result for this one as well. Meaning, the second number we're going to write down here is 2. Now, with 16's case, in 16, you can have both of the numbers before it being either even or odd, because one number could be 32 and the other could be 5. Because as you see, if you just simply test it out, you see it works. And just similar with the previous two, the first two we wrote, 2 would still just end up as the next number being 4. Now, the numbers that could be before this are going to be 64 for 32, because the only number that could be before 32 is even, since if the number before 32 was odd, then it just won't be able to get that 3n plus 1 for 32. So that means the number before 32 is even, and we have 64 for it. Now, for the number before 5, it can't be odd either, because if you plug in a number for 5 and then try to get the 5 result, it just won't ever work. Because as you see for 5, if you subtract the 1 and get the 4, and then try to divide it by 3, it won't be an integer, and it's supposed to always be an integer in this problem. Meaning, we would have n over 2 for before 5, and meaning the number before 5 is 10. Now for 4, we just have the normal paths we've seen before. Like, as you've seen in 4 above, the two numbers that could come before it is 8 or 1. And it'll still be the same case for this 4 as well, meaning the numbers before 4 in this case is 8 and 1. So now we've basically written out all the numbers that are in this process, and for these 4 numbers that could be for n, 64, 10, 8, or 1 could lead up to 1 in this problem. Now in this problem, it says to add up all such integers that could be n. So when we just add it up, let's just add it up real quick. 64 plus 10 plus 8 plus 1, we get 83. So let's just mark that right now. As you see, in this problem, you can just simply solve it by working backwards and get it done really efficiently, and I guarantee knowing you got it right. But anyways, as you can see, we've solved this problem, meaning we are now officially finished.